Let's discuss about Alzheimer's disease today. Alzheimer's disease is a degenerative disease of the brain described as early as 1906 by Dr. Alois Alzheimer. There is progressive memory loss and loss of cognitive function. Now, what does cognitive function mean? Cognitive function is an intellectual process by which one becomes aware of, perceives, or comprehends ideas. It includes multiple mental abilities: learning, thinking, reasoning, remembering, problem solving, decision making, and attention. Alzheimer's disease is the most common form of dementia. Dementia is a general term for declining mental ability which affects the performance of daily activities and routine. Dementia became the leading cause of death in 2016 for Australian women, surpassing heart disease. It is the third cause of death for men. In 2019, there is an estimated 400,000 Australians living with dementia. Without a medical breakthrough, the number of people with dementia is expected to increase to 500,000 by 2028 and 1 million by 2058. Alzheimer's disease is more specific and is the most common type of dementia, accounting for 80% of cases. Short-term memory loss is one of the earliest symptoms. There are two types of Alzheimer's disease: sporadic and familial. In the sporadic form, the disease is usually diagnosed after the age of 65 and is by far the most common form. In the less common familial form, the disease runs in families and usually affects people in their 40s or 50s. Now let's talk about the anatomy of the brain in relation to Alzheimer's disease. Brain is full of cells called neurons. Each neuron has a body which contains the genetic blueprint that directs and regulates the cell's activities. Dendrites are the branches of the brain cells or neurons which collect information from other neurons. Axon, the third part of the neuron, is a cable which transmits messages to other neurons. In Alzheimer's disease, many neurons stop functioning, lose connections with other neurons, and die. When neurons and other connections are destroyed, it involves memory, including hippocampus. Hippocampus or hippocampus lies below the temporal lobes of the brain. Later, it affects the areas in the cerebral cortex responsible for language, reasoning, and social behavior. Over time, a person with Alzheimer's gradually loses his or her ability to live and function independently. Ultimately, the disease is fatal. Now let's talk about amyloid plaques. Beta amyloid protein involved in Alzheimer's comes in several different molecular forms that collect between neurons. In the In the Alzheimer's brain, abnormal levels of this naturally occurring protein clumps together to form plaques that collect between neurons and disrupt cell function. Now let's talk about neurofibrillary tangles. Neurofibrillary tangles are abnormal accumulations of a protein called tau, or it's pronounced as TER, that collects inside neurons. This is a protein, an important component of nerve cell, helping to maintain their function and structure. In the brain, distortions in the protein's molecular shape is associated with the onset of Alzheimer's disease. Healthy neurons, in part, are supported internally by structures called microtubules, which help guide nutrients and molecules from the cell body to the axon and dendrites. In healthy neurons, TER or tau normally binds to and stabilizes microtubules. In Alzheimer's disease, however, abnormal chemical changes cause TER to detach from microtubules and stick to other TER or tau molecules, forming threads that eventually join to form tangles inside neurons. These tangles block the neuron's transport system, which harms the synaptic communication between neurons. It appears that abnormal TER collects in certain regions of the brain that are involved in memory. So the beta amyloid clumps into plaques between neurons, and the TER seems to spread throughout the brain. Now let's talk about chronic inflammation in relation to Alzheimer's disease. There are scavenging cells called glial cells in the brain to help keep the brain free of debris. One type of glial cells is called microglia, and another called astrocytes. They destroy waste and toxins in a healthy brain. In Alzheimer's disease, these cells fail to clear away the waste, debris, and protein collections, including beta amyloid plaque. There's a gene called TREM2. Normally, TREM2 tells the microglia cells and astrocytes to clear beta amyloid plaques from the brain and help fight inflammation in the brain. In the brains of people where these genes does not function normally, plaques build up between neurons. Let me summarize the situation. In Alzheimer's disease, there's an abnormal buildup of protein called beta amyloid, which forms plaques outside the brain cells and disrupts its functions. TER or tau is an important protein component of nerve cells, helping to maintain their function and structure. In the brain, distortions in the protein's molecular shape is associated with the onset of Alzheimer's disease. Then, when it comes to the microglia and astrocytes, the scavenging cells, they collect around neurons but fail to perform their debris clearing function. In all these situations, the brain cells seem to dysfunction and die. That is the story of Alzheimer's disease. So far, we know how Alzheimer's disease builds up, but no solutions have been found to arrest the damage to the brain cells. People who live a healthy lifestyle, especially from midlife onwards, are less likely to develop Alzheimer's disease. This includes doing regular physical exercise and keeping to a healthy weight, not smoking, eating a healthy balanced diet, and drinking alcohol within limits recommended by your doctor. Keeping physically, mentally, and socially active will help to reduce the risk of developing dementia. I hope you enjoyed this video. Thank you very much for watching.